for you. Okay, so in this question, they say in the circuit diagram below, each cell has a voltage of 1,5 volts. Use the diagram to answer the questions that follow. Right? So we can see this is one cell. When you have this long and short line, that's one cell, two cells, three cells, four cells, five cells. Do you see that? So we say 5 times 1 comma 7, right? Because they say each cell has 1 comma 7, sorry, 1 comma 5 volts. That gives us 5 times 1 comma 5, and that gives us 7 comma 5 volts. Right? That's number 8.1. Right? Okay. So let's check the next questions in this past paper. They say calculate the following, the total resistance of the circuit. Okay, so we can see here's 1 in series and there is 3 in parallel, right? So that is 8.2.1. 8.2.1. Okay, so let's go about doing that. Okay, so let me just check here quickly. So it's 6, 4, and 3. So in the parallel resistor, 1 over RT is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3, right? And so on. Okay, so we can see this one is going to be equal to 1 over 0, 0,6 plus 1 over 1 over 4 plus 1 over 3, right? And to be able to find this, we have to make the denominators the same, right? And we can do that by finding the lowest common multiple. Okay, and looking at it, I think the lowest common multiple is going to be 12, eh? Yeah. Okay, so the lowest common multiple is 12. Okay, this goes in to 12 two times. We need to multiply the top and the bottom by 2, eh? So that's 2. 3 times top and bottom by 3. So that's 3. 4 times we multiply the top and the bottom by 4. Okay, so the total is going to be 2 plus 3 is 5 plus 4 is 9 over 12, which is equal to 1 over RT. So RT, therefore RT is going to be equal to, if we multiply it by the inverse, it's going to be 12 over 9. Eh? Okay. And then we also have that one that's still in series, which is this one over here, 2,7. So we need to add that also with it. So it's 12 over 9 plus, let me just shift this a little bit to the right. Let me just check here quickly, 2,67. Let me just shift this like this a little bit. I'm just going to leave that like that. So then this is going to be equal to 3,97 ohms. Okay, I'll save this one. Okay, 3,97 ohms. Okay, so let's check the next one. Did you have any questions with that one?
No, sir.
Okay, you're fine. All we did was we added the resistors in parallel with the resistors in series, eh? Okay, so now let's say what um, is the amps by ammeter 1, eh? And we can see ammeter 1 is measuring the whole circuit over there. Okay, so to calculate the current, I is equal to V over R, eh? We use that formula. Okay, so therefore so we already calculated the voltage of the entire circuit, which is equal to 7,5, eh? Divided by the total resistance, which was 3,97 that we calculated over here, eh? Just send this one to you. Okay. Okay. Um, so let's check over here. So like we said, we just calculated this one. We can see that the total voltage is 7,5 and the total resistance is 3,97. Okay. Um, so let's do the next question. Okay. So we found the reading. Do you have any questions with 8.2.2?
No, sir.
Okay. So now we need to find we need to find out what is the volt reading over here with that resistor.
Yes, sir.
Okay. Um, so let's just check. So we found out what is the current flowing through the system. Um, this was 8.2.2, right? And 8.2.3. Okay. Again, we use the formula. I is equal to V over R. Um, and we calculated this. The current in the circuit is 1.88 amps. Okay. Okay. Next, we need to find out what is the voltage. What does it say? The reading in the voltmeter 2 is over there. What is the voltage over here? Okay. Um, so we know this resistor was equal to, what was this resistor equal to? 2.67, eh? So that's going to be, and the current in the system is 1,88 times by 2,67. And that is going to be equal to the voltage, right? Let me just move this. Okay, so we can see that the voltmeter reading in voltmeter 2 is going to be, let's just check what that is, 1,88 times by 2,67. Okay, and we get 5,01 volts. Okay. Do you have any questions with these two?
No, sir. So
Okay.
far, I don't have any
Did you
questions.
guys do these two formulas yet?
No, sir.
Okay, you guys haven't done these yet. Okay.
Yes, sir.
Okay. So you guys just did the resistance, resistance in series and parallel.
Yes, sir.
Okay. Okay, I think we can leave it there for now.
Okay.